Now ultimately the end goal here is for resource sharing. I want to be able to get from my desktop PC over to a server farm somewhere that has information that I need to accomplish my job. But there's other reasons besides resource sharing, as far as client to server type interaction, that would cause us to build a network. Peer-to-peer file sharing within a data network is certainly important, as well as sharing resources coming from multiple workstations accessing a single printer, or the ability to intercommunicate with each other using technologies such as voice over IP or video over IP at your desktop. We also build networks from the idea of that we want customers to be able to access our data in some fashion so they can get information about our company. For instance, our external web presence or email servers so we can communicate with our customers. That brings us to network user applications. Now, very different from end user applications in the respect that end user applications, like things like Microsoft Word or Excel or any kind of document creation type application, is designed simply to work at a workstation and create data. The network application portion is really for inter-host communication. Things like web browsing, where I'm going from a client to a server with various different web browsers. Instant communication tools where I can IM back and forth between users or between me and a customer. Things that we might use within our organization for collaboration. New programs like Groove or SharePoint applications, or ways to do shared whiteboarding or other means to collaborate and identify and do team building type applications in order to share information live with other users. As well as, of course, file sharing applications or email applications. Any kind of application that's designed for inter-host communication could be classified as a network user application. And these are important to understand because this is the reason why we're building the network in the first place. From a user's perspective, this is what they're seeing on their end, and they're going to be explaining to you that their web browser is acting slow today, or it takes a while to transfer a file via the filing sharing application that you've given them. So in that respect, you've got to tune yourself from a troubleshooting perspective based on the end user's experience of the network. And their experience is really based upon their network user applications. Also, it's important to understand how a user perceives the network based on the types of applications. Now, I mentioned those applications there, and those could be classified as interactive applications. Applications that require a human-to-machine interaction or human-to-human type interaction if we're going from person-to-person with something like IM. But there's other kinds of applications and reasons why we build a network. Things like batch applications that are machine-to-machine or not really direct human interaction. Things that are scripted or otherwise designed within our network to happen. Automatic inventory updates or batch backup applications to back up data. These don't have to have the same level of bandwidth or certainly the same level of responsiveness as we expect in our interactive applications from our end users. There's another type of application that's important to think about, and that's also real-time applications. When we're doing voice over IP or video, this is when we have issues where latency becomes a very critical thing as far as building our overall network and making sure it's secure, redundant, and reliable so that the packets arrive in such a manner that they're not molested or otherwise modified, and certainly arrive in a timely manner. So in this case, we talk about, the voice over IP is a great example here because we've got a latency window that's really easy to identify. It's 150 milliseconds. It goes from my mouth to your ear in 150 milliseconds or less. The voice over IP traffic should sound okay. Of course, the faster the better, but this kind of real-time window is important to understand as you're building your network. If you go above that and can't rely upon the network to provide you that level of latency end-to-end, then you're going to have problems and your end users are going to be complaining about it. The advantage here is if you have lots of problems with it and it's voice over IP, they can't call you.